MapleSoft is a world leader in engineering simulation and analysis with deep experience in virtual prototyping of automotive systems throughout the world. MapleSoft has completed projects for Toyota, Honda, Aisin AW, Ford, Chrysler, and Bosch, and these have led to the development of specialized libraries for modeling powertrain systems such as engines, motor generators, batteries, transmissions, and tires. In this presentation, we'd like to introduce you to the principles behind the 4QMET transmission through the simulation work we have carried out with our tools Maple and MapleSim. The 4QMET is an innovative design of a continuously variable transmission from CVeT Power Corp. This elegant solution addresses several issues with existing CVT designs and eliminates the need for belts and pulleys that require external power to actuate them. This typically happens through significant hydraulic power from the engine, which adds to the complexity of the system and reduces overall power efficiency. 4QMET stands for 4-Quad Mirrored Energy Transfer Transmission, which reflects a key aspect of its operation. For the purpose of presenting this concept, the engineering simulation tool MapleSim has been used to illustrate the physical relationships that are employed in the 4QMET design. At its core, the 4QMET makes use of two differential gear sets and two motor generators. Before we discuss the design in detail, let's consider how a differential works through the use of MapleSim. Since the inception of the motor vehicle, differentials have been a crucial component. When a vehicle is steered, they allow the driven wheels to turn at different speeds. We can illustrate this relationship by applying a brake to one drive shaft to slow it down, while keeping the engine shaft speed constant. We observe that the other drive shaft speeds up, while the speed of the engine shaft is constant. We can explore this further by letting the engine shaft run freely and connecting motors to the drive shafts. We see that the free shaft will run at a constant speed that is determined by the combination of both motors. When both motors are spinning in the same direction, we see the output shaft spinning. If we then slowly reverse one of the motors, we see the output shaft slow down and fully stop once both motors are spinning at the same speed but in opposite directions. Now here's how the 4QMET works. The drive shafts and motors of the differential are uniquely coupled to a second differential to provide the 4QMET effect. With no load applied to the drive shaft through the motor generators, the output differential is effectively decoupled from the engine, something that cannot be achieved with existing CVT designs. As load is applied by one of the motors operating as a generator, the energy is mirrored to the other motor, and the output shaft will begin to rotate, providing power to the wheels. The ratio of the engine speed to the output shaft speed can be determined by controlling the mirrored energy transfer between the two motor generators, providing precise speed control through software-controlled power electronic drives. This eliminates the need for external energy to operate the 4QMET transmission. Now let's consider the operation of the 4QMET in a vehicle. The primary advantage of being able to continuously vary the gear ratio is that whatever the speed of the vehicle, the engine speed can be set to its most efficient operating point. This efficiency advantage is most prominent during city drive cycles, where the vehicle is making many starts and stops. Under these conditions, vehicle engines can't operate at their maximum efficiency, and this is particularly true for service vehicles such as delivery trucks and buses. If we compare two identical vehicles, one with a conventional automatic transmission and the other with the 4QMET transmission, we can see that during the simulation of the two vehicles operating over the same standard city drive cycle, the average fuel consumption improves by almost 45%. That means that on a full tank of fuel, the range of the vehicle with the 4QMET will be almost twice that of the one with the conventional transmission. In commercial terms, if a typical vehicle consumes about 15,000 liters of fuel per year, for the same drive cycle, a vehicle operating with the 4QMET transmission would consume almost half of that, saving between $8,000 and $9,000 a year